Well, it's Sunday, and I've done my church service via Zoom. We're going to make something out of nothing today. I've got 3 LCL radios here. They're all out of the scrap bin. So we will see what's what. Don't think there's a set of knobs between them. That's more or less complete, that Enterprise. But then that's got a full power lead. I've often found these have been scrapped just to nick the mounting kit off the output transistors. Yeah, I think we'll do that one. I mean, that's quite well worn, isn't it? I think somebody's had years of fun out of that one. So that's an Enterprise. That's an Enterprise. They're the ones with the green display, and that's an Enterprise as well, also with the green display. That's quite surprising. So I think that's the wrong knob. So we still haven't gained a full set of knobs, but that doesn't matter. So we'll do this one because it looks promising. Oh, well, I wouldn't say it's very promising looking around that part of the circuit. It's had a right load of work around the phase lock loop and around. I think we'll start by using the cleaner on those, because there may well be some bad bit of soldering that isn't obvious until it's being cleaned with isopropyl alcohol. So these radios actually work better than most people think. So well, I like them anyway. Okay, so I don't know where the normal brush is, but I've got Mr. Chippy's toothbrush instead. Unless you deflux it, you just can't see where the dodgy bits are. This is pure isopropyl alcohol. We use it for cleaning records. Some of you might know I've got 20,000 7-inch singles here. Some of you won't be caring an iota about that. Yeah. Got some right dodginess here. I don't know what happened to the solder sucker on this bench, but it's now kind of broken. So I keep having to pinch one off Mr. Chippy's bench. So I've got his best toothbrush. I'll be having his solder sucker, and I have ordered a replacement. The end's disappeared. Where's the end gone? Dunno. Right, so we'll have a look at this. Got a wicked dry joint there. Normally I would unsolder that. There's a dry joint there, but it's a pin that doesn't go anywhere unless it does on the other side. To be honest, I'd be better off putting the whole radio through the dishwasher. Okay, well, we'll see. I can't see anything pinched out of this. Right, we'll power it up. I'll just make sure it's got a 2 or 3 amp fuse in this, and not like a 10 amp car fuse or something ridiculous. 2 amp, that's fine. That's never been used, has it? It's a new power lead. Beautifully tinned ends, not been anywhere. Just one of these kind of new returns. But when you look at the front, it's got plenty of wear. It's had loads of use. Anyway, I can't run that through my mind as to why. Now, you don't need a mic on these for receive to work. It's last used on channel 19, so we'll put it to channel 20. I'll plug in my test instrument speaker, the radio set to high power, plug in the test instrument. Well, if it worked after doing those 2 rather obvious dry joints, only obvious when you clean the board. Okay. So what we'll now do is we'll select picture in picture, and then if it does go into transmit, which it does, we'll both see it. Okay. It's doing 2.1 watts. If I pull the circuit diagram off the printer across the room, I know we've done the Enterprise and the Economy before. Just have a quick look at what we need to be tuning. L10. L10, L11, L12. L10, 11 and 12. How do we know which those are? I'm going to have to pause the video and print off a layout. I've no idea where the highlighter pens went to. I've ordered some more the other day, so it was quite useful doing them in red and green and yellow. Right, this is scanned from the instruction book. Luckily, I had the sense that when we had these sets at the time, that I always scanned an instruction book. Well, I photocopied them. We didn't have scanners then, and we had a good photocopier. So, what did I say we wanted? L10, 11, L12, wasn't it? Don't think 12's variable. So L10, L11. L10, L11, L12, and then you've got those. Okay. So we're on the 3 watt scale, and we'll start at 2.1 watts. So we're at 2.4 watts. .7 watts, 0.8 watts. Probably about where we're going to get to. Because these are interactive, it's always best for me to go backwards and forwards on them. See, they wouldn't have time to do this at the factory. They have a minimum standard for them to come to. And out they go. Now there's a filter one probably under there. There is. We'll do that with the. We'll check that with the spectrum analyzer, because it might have been fiddled with. This is the one you're not supposed to fiddle with, because it does the second harmonic. So we'll check that with the spectrum analyzer. Okay, so we're doing 3 watts. Right, we'll look at whether it's on frequency. With 27.79125. I tell you what, it's not far out. A surprisingly high quality trimmer capacitor. I actually went the right way, but too far. It's going to be one of those. That'll do me. 27.79126. Now we'll look at the deviation. Go back to the other camera. Do a quick whistle test. Wallow. Oh, that's far too loud. Any idea which one is deviation? I think we've only got a choice of 2. Let's go for that one. Okay, we'll go for that one. They're both set to full, whatever they are. Wallow. Wallow. This is a bit weird. 1, 2. It doesn't like 1 kilohertz. Wallow. Wallow. How weird. Just see what it sounds like on our monitor receiver. Testing 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Okay. Right, well that's done. So you get no meter, no transmit light. That's really reassuring, isn't it? I'm all for a transmit light. Okay, so we'll turn our attention to receive. Oh, no I won't. We'll look at low power. So we should have 0.4 of a watt, and we've got 0.22 or something like that. And that's supposed to be adjustable. Well, I've fiddled with that, haven't I? And that's the one. Just give that a quick spray. I spotted on the circuit it was adjustable. There we are, 0.4. And then back to normal power. It's doing 3. Good. So, over to receiver, as I said. So we'll dial in 27.79125 into the signal generator. I'm not expecting this to be anything like as sensitive that Danita 3000 UK I did yesterday, which was off our clock. But it could well be as good as that Unidem based realistic we did. I'm going to buy a second signal generator for bench number, is it 4? That's the spare-ish slot where I have the HP signal generator. I'll get another one of those second hand, and then we'll be able to do adjacent channel rejection readings. In other words, bleed over. I get a lot of comments regarding bleed over. I mean, I really don't care an iota because I'm in the middle of nowhere, so I don't get any of it. And gone are the days when every other house had a silver rod on a terrace property, you know. So unless people are operating with naughty high power and things like that, I can't see that it's an issue. But we could do figures by having 2 signal generators and some clever equation, which I'll have to look up in a textbook because I have a memory like a sieve. Okay, so we now have 2779125, and what we'll do is we'll go over to the oscilloscope. I'll put S9 equivalent on the radio, on the signal generator onto the radio, and the detector is likely to be where? Oh, good grief, it's anybody's guess. I think we'll better look at the circuit diagram. I have a feeling in my bones that it's that one. So if we look at the demodulator IC, the MC3357, L5 is going to be the detector. And L5 is... I've got the circuit upside down. No, I haven't. That's because it's mirror image. That's clever of them, isn't it? It's like that, mirror image. So, L5... is that one. I can't see making much difference. That's definitely the detector there. L5. Oh well, we'll fiddle with them till we get the result we want. And that's what I've got as to me, that's the detector. So what's that? L4. Where's that in the circuit? Yeah, okay, I'll let them off as figures. Okay, so that's made a massive difference. And I'm getting the best sine wave. You can have it lopsided, so it's non-sinusoidal. Okay, so we'll go through. We'll get that set onto the, and I'll put the spectrum analyzer on for later. 1, 2, 3, 4. I think we're on 4. That's it. So try and go through these in a sensible order. We really want L1, 2, 3, 5 is going to be IF. So 1, 2, 3. 1, 2, 3. One, two, three. The one I messed with. Can't you tell I did? Go back on the others. Then we'll recheck the detector. And that's it. So those two down there, what are they? L8 and 9. Yeah, they're to do with the V0, looks of that. Well, that seems to work nicely. I don't think it's got a squelch preset. And I think you get what you're given on squelch. So let's look at the cyanide. Can we get 20 dB out of it? We can. And I say this is always subject to noisy transistors. So LCL Enterprise 20 dB cyanide is 2.7 microvolts. (12 dB cyanide, which is industry standard, 0.87 microvolts. It's not too scary. (10 dB cyanide, 0.7 microvolts. Yeah, well, we've had brand new Albrecht sets doing worse than that. You know, especially the one that cost 240 quid. Right, we'll turn the volume down, put the spectrum analyzer on, go back to transmit. Oh, there's a nasty one up there. Yeah, it's the second harmonic is nearly. So that's our fundamental frequency, and that's our second harmonic. So if that's doing 3 watts between them, no, we're doing 3 watts because it's selective. We've got another 1.5 watts by the looks of it there. So let's see whether it's that coil in there can improve that. So I'll just run through these again. Yeah. Okay, we're going backwards and forwards and backwards and forwards. We've now got it at round about minus 72 dBm. So it's about at the limit which is approved under MPT 1320. So it's not good, but then the filtering isn't good and it's a cheap set. But it is within spec. And with the 3 watts we're getting out of the radio, which is still there, I'll just change cameras. We're still getting 3 watts or 2.99, and that is 27 megs because this is selective. So this isn't looking at the 54 meg portion. So there you go. So if you do the maths, what's minus 70 something dBm? I don't know. Not going to look it up either. So we're in spec now. But that wasn't easy to achieve. And I've step tuned. It was maximum and then plus a bit, maximum and minus a bit, maximum and plus a bit to achieve that step tuning to get rid of that down to minus 76 dBm. And to be honest, the filter had little effect. But there you are. Right, well I'll attempt to put it together. Oh, let's see where the squelch is. Okay, so maximum squelch. Let's go down to the attenuator. So I've got the squelch on maximum on the radio. So let's turn this. I like it to be 100 microvolts till it comes in, but this isn't adjustable. So 1 microvolt, 3 microvolts, and it comes in. So it's pretty wishy-washy. So let's have it on minimum, turn the radio to minimum squelch, set threshold, switch the signal generator on, comes in at 0.3 of a microvolt, we lose it at 0.12, comes back in, 0.1, so it's pretty sensitive. So we've seen worse. I say it's developing 3 watt on 27 megs. It's developing a bit elsewhere but within spec now. But it wasn't in spec as it came. So let's see if we can find enough bits of case to put this together. So we've got, I don't know if we've got a speaker lid. We've got that bit of case. If we've got more bits of case, we could put more of these together. Well, you can see that capacitor in this one has blown. Yeah. Well, I think what we'll do, we'll put these case sections through the dishwasher, and I'll just test this speaker before we go any further. That doesn't look promising. Let's give it another go. Yeah, we're all right. 7.6 ohms. Couldn't have got the prods on right first time round. So I'll just loosen those off enough to get the speaker out. Or we're going to have to take one out totally. Let's try it that way. There we go. Right, I'll shove those through the dishwasher. I'll put the two remaining knobs through the dishwasher, and I'll come back to record in half an hour. Okay, so now we've got it back out of the dishwasher, and we've got screws in it, and I've got the knobs to put on. What knobs we've got, that is. So on off volume, squelch. I make sure we're on high power, and I can't reach that because it's recessed, so I'm sure we can turn that round with a screwdriver. That's a great big screwdriver. We'll turn it round with that. Well, my goodness. One down, Roger. One day somebody will explain to me what these echoes are all about. Right, we'll have a flick round. Okay, so here we are. It's not usual we even pick anybody up. So we're doing on the air test with that, bearing in mind it's 3 watts, so I don't know what Mr. Chippill here is like around Scratchy Corner, but at least those 3 watts are on 27 megs. and we haven't got 50-50 sharing with a harmonic. So the clear reason to me this has been discarded is that there's those very rather wicked dry joints underneath, and they were being hidden by the flux from some soldering. There's nothing really wrong with the soldering, but the flux was covering up the dry joints. So really all that needed to happen is that we needed to run the isopropyl alcohol over that with Mr. Chippy's toothbrush, which we did, and then those dry joints were obvious, bringing this set back into full operation, and a quick tune-up has brought good results. Some previous screw driving has obviously caused that harmonic, which we did have to reduce to a legal limit level. So there you are, the basic Enterprise 40. These were about 1982, and I remember the recommended price being £49, and I saw these cleared as little as £14.99. They were the days. Thank you for watching.